100 clicks per revolution, and just picked up a few so that I could actually look at the e-stop up here where it's out of the way, and then ribs around the outside with screw holes. Welcome back to Cloud 42, I'm James. Today we're back on the surface grinder automation project. If you haven't seen the previous videos in the series, I am in the process of converting a manual surface grinder to fully automatic using ClearPath servos and a ClearCore controller. Today we're getting started on the control panel. The development process for something like this requires an enormous amount of time. I've been spending every free moment for the last couple of weeks sketching ideas, buying parts, designing in CAD, 3D printing, testing, and repeating. And I finally have something that's developed enough to show. It's not done, but it's getting there. For the main controls of the surface grinder, I am planning on using this 7-inch HMI. This is a touchscreen HMI. This one comes from 4D Systems. And the only reason I picked this is that this is the one that the Technic engineers recommend for use with the ClearCore. They have libraries for it. It seemed like a pretty good place to start. So the real question though is, where should this be located? My initial thought was to put it on some kind of a console right down here on the front of the grinder to make it nice and easy to use. There's some concern about having it here. Obviously, we're generating a bunch of grinding grit and dust up here. If we're using coolant, there's going to be mist. If we eventually go with flood coolant, there could be the potential of a little bit of splashing. So this may not be the ideal place for it, though they do have versions of the HMI that have a bezel that attaches with adhesives rather than this one, which attaches from behind, and that does a better job of sealing it. The other obvious place to put it would be like up on a console up here off of the side of the column, and that would put it up where it's out of the way. This is where, you know, the control might be on a typical CNC machine, and I like that location, except when I'm doing things like trying to touch off the wheel on the workpiece, having to bring my head down and look in from the front of the chuck at the same time as I'm trying to operate something that's up here out of my line of sight seems pretty inconvenient. If it were right down here, I could put my head down so I could see underneath the wheel and I could operate the display at the same time. Now the other thing about this though is that I don't want to be limited to the touchscreen. The touchscreen is great for configuring parameters, but it's not necessarily that great for just operating the machine. So I would like to have some physical controls also. In particular, I want an MPG wheel so that I can actually just crank it and move the machine and jog it step by step very precisely. And then probably some selector switches to select the resolution and the axis to control with the MPG. And it would also be nice to have start and stop switches for the grinding cycles. So I want to do something like that, and I really would like to put it down here, but I'm not exactly sure how I want to do that. I just need to get some switches. I need to kind of play with them on the bench and get an idea of what I would like to have. Here's a little closer look at this HMI. This is just a 7-inch resistive touchscreen. They have these in capacitive and resistive, so they'll have a plastic coating. They also have non-touch versions of this, but that's not what I wanted for this application. And as I said before, they have some that have like a glass or a plastic cover over them with a bezel that seals down with adhesive. And these LCDs have a controller on the back, and they have a piece of software that you can use. Actually, they have several different software options you can use to design the user interface for it. And so all of the graphics and the control for that are all embedded and running in the processor in the HMI, the human machine interface screen. And then there's just a 30-pin flat flex. And in my case, I have an adapter that'll allow me to connect this directly to a ClearCore via serial. So the UI will be coded and running inside the HMI, and it'll be communicating with the ClearCore that'll actually be running the machine. But in addition to this, I want some physical controls. I mentioned that I want an MPG dial. So this is 100 clicks per revolution, and this is an encoder, a quadrature encoder output, TTL level. So this can be connected to the ClearCore directly so that I can run this as fast or as slow as I want, and it'll maintain a counter of the position of this so that I can use it as input. So I can, select the x-axis and I can move it by increments. And I want to have a dial so that I can select the axis, and another selector dial so I can select the resolution. So I could just select the y-axis, select tenths, and I could, lower the wheel by 10,000ths of an inch, 1 click per tenth. And, of course, since it's all digital, we can do the same thing in metric. And that should be a much better interface for actually operating the grinder, especially if I'm trying to do something like dial down the height to touch off, or trying to advance it a couple of tenths to take another pass, or trying to advance it a few thousandths to take another dressing pass. So this feels pretty good. I just found this on Amazon. It was relatively inexpensive. We'll see how it actually works. There are some much more expensive ones that can be purchased if you have the cash. So if this ends up not working very well, it's pretty easy to swap this out for something better. For the rotary switches, the selectors to actually select the resolution and the axis, I wanted to use a nice clicky selector switch with a chicken head knob. I really like this style of knob. They're retro, they're nice. I've had some people tell me that it's a little bit incongruous with the style and the design of everything else, but I don't care. I really like the idea of a clicky knob, point it to which axis you want, turn the MPG dial. Now I bought these on Amazon and they are complete garbage. You can see here on the back that as this rotates, there's a wiper that moves between the fingers. So there's a little wiper here that goes between sets of fingers on the contacts. And you can also see that on this side, that's going between the fingers, but on this next one, it's on top of the fingers. And it's because this thing is all bent up. I mean, it got damaged in the package. All the parts were just thrown in a bag loose and shipped. This one's completely mangled. I've got another one here. This one has half of the threads ripped off of the stem. So the nut only goes part way up and then just spins because half of the threads on the stem are missing. These ended up being a really big disappointment. The other thing is there's no flats, there's nothing to keep them from spinning. I played around with modeling them so that something would grab these screw heads and keep it from rotating. But in the end, I decided that it just wasn't worth it, and I wanted to actually get some proper rotary switches. The ones I finally settled on are these ones I bought them from Mouser. They're made by Gray Hill, and these are not cheap. These are between $30 and $40 each, but they have them in every kind of configuration imaginable, up to 10 positions. These are just 4-position switches because that's what I wanted. And then I also ordered some nicer quality chicken head knobs for those. And they're hard to rotate without the chicken head knob on them, but these just feel a lot better. They're easier to rotate. They have a nice positive action, and they're actually sealed, as opposed to these things which are just open and could easily get contaminated. And I have no idea how much I can trust those long term. So these are the ones that I think I'm going to go with. They're quite a bit more expensive, but I think this is a case of you get what you pay for. I thought I could get away with these, but I hate them. They're no good. These ones should be perfect for this application. I'd also like to have an e-stop switch, and I picked up a few different styles. That is gnarly. Definitely not putting that on any machine that I own. These ones are much nicer. These both have anodized aluminum knobs. But this is the one that I really like. It's nice and compact, nice and smooth. Definitely going to go with that one. And then for push button switches, for the start and stop cycle buttons, I did basically the same thing. I just went through Amazon, found a bunch of different styles, and just picked up a few so that I could actually look at them and see how they work. These ones ended up being pretty much identical, so I actually ended up with kind of 3 different styles of switches. So the way these work, there is what they call an operator, which is the actual push button itself, and then there's a switch assembly that goes on the back. And these switch assemblies are set up so that they can be stacked and installed on the back in different combinations. And most of these come with one normally open and one normally closed so that you can use them in either configuration. You can take off the one you don't need. You can actually stack more on the back, and you can make as many different switch contacts on one operator as you like. But there are a couple of big differences between these just in terms of how they mount. These ones are designed to mount with screws. So the way this works is you put this through the hole in the panel, and on the back here you can see you have these screws on the side that go in at an angle so that you can put that in and then take a screwdriver and tighten that screw down so that it bears against the back of the panel and pinches it against the head of the operator. And this works just fine in a metal panel, but I think at least for the prototype I'm going to be using a 3D printed plastic panel, and what I've found is that there's a gasket in here that gets compressed against the panel, and then when this screw comes up and bears in just a couple of points, it ends up distorting the panel and flexing it. So I really don't want to use this style of switch just because it limits the flexibility. This style of switch, however, has a threaded ring. So this has a little latch that you turn to pull the switch off the back of the operator, and then the operator itself has a threaded ring. There's a little rubber gasket here, so you put this through the hole in the panel, put the ring on the back, tighten that down, and because it bears all the way around the sides, it won't distort a flexible plastic panel. And then the switch is the same thing. There's a body here, and then there are switches that snap on the back. This one has one normally open and one normally closed. And this just slots in. You have to get it rotated right. It slots into little cam lock grooves, and then push that over to lock it. So you can actually mount the operators in the panel, get it all ready to go, and you can actually swap out the switches later if you want to change something, or if they wear out, you can leave the operator in the panel. It also makes it easier to construct the panel and then add the switches later when you're actually doing the wiring. And of course, you could unlock this, pop it off, leave the wires connected to replace the operator, or replace the operator with a different style, or replace it if it gets damaged. So then the interesting question is, how do you lay out all of these parts into a usable control panel that actually makes some sense? When I don't really have any idea exactly what I want, just throwing out some sketches, grabbing a stack of paper, grabbing a digital tablet like this really is a good place, I find, to start. So I just started kind of throwing together some sketches of some different ways that this could work. One with the HMI horizontal, one with it vertical. Got a place for the MPG, my little selection dials, the e-stop and the start and stop cycle buttons. This seems pretty crowded, especially when you realize the aspect ratio of this isn't at all what I've represented here. It's actually much wider. I tried kind of putting it vertically to see what I thought about that, kind of what does that do for the panel. That seems pretty reasonable, but this does seem pretty crowded. I'm not sure I could get in here and change these dials without accidentally bumping the MPG, which could be disastrous if we actually run the wheel into something. I kind of played around with some ideas of what the DRO on the display might look like and how that might fit into here. Again, I kind of like this orientation. This would be like for a panel that would sit up on the side of the machine. I kind of like that. I'm not totally sure I buy the vertical, and I'm not totally sure that there's enough space in here. Same thing with this, going back down horizontally again, just kind of refining these ideas and different locations for the start and stop buttons. I do like having the MPG and the selectors below the screen and the cycle start and stop over here. That feels pretty good to me. Still not totally happy with that. And playing around with this, I tried throwing some stuff on the right, but what ultimately was the inspiration that I think really kind of broke me out of this part of the process was the idea of having a console and putting the MPG dial on the front. I really like the idea of that MPG dial on the front away from everything else. The selector switch is directly above that to select the axis and the resolution, and then the other controls around that. So I can reach the touchscreen easily. When I'm reaching over these controls for the touchscreen, there's nothing I'm going to bump. I'm not going to bump that MPG dial. When I turn these knobs, I'm not going to bump the MPG dial. E-stop is up here out of the way. Cycle start and stop are right here, and if this is on the right-hand side of the machine, those are over towards the center where I might be sitting or standing. So this is the idea out of all of this that I like the best. So the next step is to get into the computer, get models of all of these controls, and just see how it really fits. I found or created models for all of the components I want to use for the control panel. In the case of the 4D Systems HMI, I was just able to download the model from their website. I think I created the e-stop switch, and all of the other parts I was able to find on GrabCAD. At least I was able to find parts that were close enough that I could modify them so they would match the ones that I actually have that I'm going to use. Now I have these in a model here in Fusion, and I have the HMI fixed, but all of the other parts are joined to the HMI with planar constraints. So if I go in here and edit the joint, you can see there's a second motion tab, and I've selected planar motion. So then what that allows me to do is to move these around freely. They're all constrained to the plane, but I can move them around in X and Y and put them where I want. And so then this allows me to move things around and sort of play with different layouts and decide what I want to do, and just, move stuff around until it looks right. And I have the added advantage of having everything the size it actually is, so I can see if there will be any kind of physical issues with things running into each other. So I played around with this for a while, came up with this, drew a sheet metal panel behind it just to kind of see what that might look like. And then I did another version with a bent panel for the console style that I mentioned when I was showing the drawings. And this ultimately is the design that I decided that I want to go with. So I went ahead and created a proper, fully modeled panel for it. Now, I was originally going to do this with sheet metal, but then when I started playing around with an angled front console, I decided that bending the sheet metal with all the tabs to make all this work seemed like an awful lot of work, and I might as well just 3D print it. So I've got this modeled for 3D printing. I've got ribs in here for reinforcement and stiffening, and anchor points so that I can put in threaded inserts for screws to hold the HMI in place, and the PCBs that I need in here. And I've got tabs with slots through them for zip ties for wire management, and then ribs around the outside with screw holes for attaching to a base cabinet. And then to enclose the bottom, I designed a two-part base. This is done in an upper and lower part just so that these parts have flat surfaces and can be 3D printed. So if I hide the top panel here, you can kind of see how this works. These parts fit together. There are recesses in here to hold threaded inserts, tabs to give a location for the screws to go into, and then I've got a little overlapping rib in here to make sure that dust and light won't show through. And then I've got a little shadow line detail here to hide any imperfections in how the panels come together. So when this whole thing goes together, we get a nice closed case, goes together with flathead screws all around the perimeter, and this should fit easily on the front of the grinder. You can see how those shadow lines kind of fit together there and will hide any imperfections in the fit. Got some holes on the back here so we can connect it to the front panel, and then I designed a flexible 3D printed grommet so all the wires and cables can come out the bottom here, and then we can put zip ties through these slots to sort of pinch that grommet down and seal out dust. And then the whole thing will just mount right here on the front of the grinder. You can see I plan on mounting it with 4 screws through this into the aluminum plate that I have there. And then I don't want to actually put any holes into the grinder body itself, but I've got these tabs with a couple of M8 set screws that I can just use to run those down so they make contact with the top of the grinder, just to keep it from rocking or flexing. And then for the markings on the front, I should be able to mark those with a laser. We'll print this in black ABS, and the laser marks should show up white or light gray. So that should give us some good markings for the front. Let's go make this thing. I'm going to try to print all of these parts out of ABS. Something like PLA would print really easily, but it would be pretty brittle. Something like PETG would also print pretty well and be easy to control, but it's a little bit on the flexible side. So I wanted to go with ABS to have something that's strong and relatively rigid and impact resistant for this application. And what I'm going to use is eSun ABS Plus. The only reason is just because that's what I have. It's a lower warp formula, so these larger parts should be easier to print. But in the end, this is going to be a challenging print. You can see these parts just barely will fit in the Bambu Lab X1 carbon. So in terms of ABS parts, this is going to be challenging. The front panel will just print with the panel side down. I did enable some organic supports here, so that we'll have some support in this large round hole on the back, but none of the rest of the parts should require support at all. I did add some little discs here to try to hold these front tabs down, just to make sure that those don't curl, and everything else fits on the third plate. So all in all, this plate's what, 3.5 hours, this is 5 hours, and this one is 6 hours. So we've got many hours of printing. Let me get these sent off to the printer, and let's get the parts. At first glance, the parts off of the printer look pretty good. They look pretty flat. They're not perfect. They curl just a tiny bit, but nothing like, you know, what parts like this would do in a pure ABS. The ABS Plus is pretty good, though we really are pushing our luck with parts this large. You can see that on the surfaces that are down on the bed, there's this sort of white hazing, swirling, and what that is that's where the plastic was stressed as it released from the bed as it cooled. And we can generally take care of that with a heat gun or a torch. You can see those marks just disappear with the torch. You do have to be pretty careful that you don't overheat it and make it flexible again and distort it out of shape. But if you're careful, you can generally get rid of those white marks, or white marks where you scraped off or removed support material. All that should come off pretty easily. Now we've got a whole bunch of threaded brass inserts to go in, and I'm just putting these in with a soldering iron. I do have a nice heat press to put these in, but those ones that you just saw are the only ones that I would have been able to put in with the heat press. All the rest of these are on the ends of large parts, or on vertical surfaces, or on angled surfaces. So I decided it was probably better just to go ahead and do them all with a soldering iron. And those went in beautifully, and they look great. I love the look of the brass inserts in black plastic. It's pretty nice. These parts should just fit together, and we can put in M4 flathead screws to hold them together. And the first few screws are going in all right, but I can already see that this part did warp a little bit. This is not entirely straight. The 90-degree angle here isn't exactly 90 degrees. It's close. We might get away with it, but boy, this really is a big part. It was ambitious to print this in ABS. Now the top does fit on, but the angle of that front part isn't quite perfect. And again, it's because none of these parts are quite exactly flat. I'll go ahead and put in the screws and see. That little pop you heard was actually the plastic splitting, so this is not looking great. And now these parts here on the side are not lining up. I can get some of the screws to line up, but I can't get them all to line up at the same time. I think we'll just leave a couple of these screws out and go with it. I am going to have to come back and revisit this, though, to get this to fit the way I want it to fit. And if we ultimately can't get it printed in ABS or any other material, you know, I'll have to go with sheet metal. But yeah, this isn't quite what I wanted. It's close. It's real close. And honestly, for ABS, this is quite an accomplishment already, but it's just not quite close enough to get away with this. Go ahead and put it together though, and the rest of this actually fits okay. So I think as a proof of concept, this looks pretty good. I don't have time today to reprint these parts, so let's go ahead and put the rest in here. Yeah, you can see that's already cracked there along the front. This is another issue that I've seen with the Bambu Lab X1 Carbon in ABS in particular, is it just goes so fast that while the parts can look pretty good right out of the printer, they do tend to be fairly brittle, and you really need to slow it down a little bit to get good layer fusion. As I'm putting everything in here, I'm also noticing that I think the parts have shrunk just a little bit, which is typical of ABS. Like getting the screws in for the HMI was a little bit of a struggle. The screw holes were just ever so slightly closer together than they were in the model, so it fits, but it's tight. I could do with a little bit more space in those screws, or maybe scaling the part to adjust for the shrinkage in the ABS. But as a proof of concept, this is actually looking pretty good. Everything fits. I like the layout. I like how it's coming together. I really like the clicky switches and the chicken head knobs. That was an inspired choice. And when we put the whole thing together on the base, it does make a pretty nice, neat little compact platform. I do like this. We just need to get the prints to work better. This is TPU. I went ahead and printed this on the Prusa Mark III, and that just fits beautifully in the hole. And this will give us a way to route cables in and out of here without opening up a big port for dust. So you can see that goes through. We can pinch it down and put zip ties through those slots. There'll be a bunch of cables in here, but we should be able to kind of cinch that down and have it mostly sealed. Well, I think this looks all right standalone. Let's take it over and see how it fits on the grinder. Of course, when I designed this front plate for mounting all the motors on the front of the grinder, I didn't know yet what I was going to do for the control panel. So we're going to need to take this off and put some threaded holes in it for mounting the control panel. I'll, of course, update the drawings, and before this project is all said and done, I'll probably have a new front panel laser cut at Send Cut Send, just to make everything nice and neat and tidy, and to make sure that any drawings or anything that I publish for other people to use are complete. We'll just tear this down, get it off. I can see I've got one steel washer there stuck in the aluminum. Tap that. And we'll take this over to the mill and put in some threaded holes. When I modeled this up in Fusion 360, I exported a drawing showing the locations of the holes with dimensions. So we know where those need to go, and I've got all the dimensions off of the upper right corner of the plate. So I'll just get this set up in the vices. This is another situation where having two vices on the mill is pretty handy, because this is a long, awkward part and would be clumsy to fixture otherwise. You could do it, but you get a lot of ringing. Two vices makes this a lot easier. Now with this mounted in the vices, I need to locate the upper right corner of the plate, and I would normally do this with a wobbler edge finder. You've seen me do that many times, but I have a TouchDRO on this mill now. Yuri sent me one to play with, and I've been enjoying it. He didn't tell me I needed to show it in a video, but I'm going to anyway because it's working for me. So I can just select the probe function, select the right-hand button to say I'm going to come at the part from the right-hand side, and then just advance in until it beeps. We'll hit it 3 times. It'll average that coordinate, and then I'll hit the button to say I'm coming in the positive Y direction, and we'll touch off the vice jaw 3 times to average, and then we just hit the set origin button, and the DRO is set on that upper right corner. Now, I don't totally trust myself with this yet, so I'm still fiddling with it. I'll drive over to that coordinate and then look at it visually and make sure it really does look like I am on that upper right corner of the plate. And of course I am, but I'm not totally confident. It's a new piece of equipment. I'm still figuring everything out. But that is by far easier for me, at least, than dealing with the edge finder and dealing with, approaching multiple times. And I just think it's a nice solution. So I've got to put 4 M5 threaded holes in here. So we'll just drive to the coordinates and drill them through. It's really a very simple machining operation, and I would have included this in the design for the plate originally and had these holes laser cut if I knew what I was going to do about a control panel when I made this in the first place. So we're going to use a spiral point tap here. This has an angle cut on the front of the thread, so it pushes the swarf through the hole. So we should be able to power tap these with no trouble. And I've just left the mill set to the same speed, but I put it in back gear, so I'm just running the mill in reverse, which causes the tap to go forward. And I find this is pretty handy to just pop it in and out of back gear, drill in the forward direction, tap in the reverse direction, and the speeds end up being about right. It's 4 holes threaded. Get the tap out of here so I don't snap it off with my hand. Blow out the holes and try to get as much of the lubricant out of there as I can. And then I'll just use a rotary countersink to clean those up. That was the vise handle falling on the floor, by the way, if you heard that. And we'll clean up any burrs on the backside. And then this part should be ready to go back on the grinder. There it is. Installation back on the grinder is the reverse of removal. We've got 4 M6 screws that hold this plate on the front of the saddle arms. Get that tightened down, get the pulley back in and cinched down, and then it's just a matter of installing the motors. I'll rush through this. You saw me do this in a previous video. We'll just get these in here, get the belts tensioned, and get everything reinstalled so that we can get the control panel in. Now, the control panel does cover some of these screws, so I've put in provisions for adjusting them with the control panel base still installed. It's not ideal, but it's workable. Now, these are M5 screws that go into those holes that I just drilled and threaded, and the thing that's becoming clear immediately is that even though I allowed an extra 0.5 millimeter on these slots to make this a little bit adjustable, it wasn't quite enough. The ABS parts have shrunk enough that it is a very, very tight fit. The holes in the plastic part are just ever so slightly too close together, and so I can get the screws in, but they're putting a lot of pressure outward on the plastic part, making it hard to adjust. So we either need to scale the part or we need to find a different material. I mean, this is the same problem I've been fighting all along with this, is that ABS shrinks. That's what causes it to warp, it's what causes it to curl, it's what causes it to crack, and it's what causes it to not quite exactly fit. Honestly, I thought this was going to go a lot better than it is, and I can hear little cracking and crunching sounds as I tighten these down. Yeah, this is not, it's not ideal. We're going to have to revisit it. So with the base mounted, we should be able to drop the control panel in. You can definitely see that crack in the lower right front edge there. And it sort of fits, but you can just see it's flexed a little bit. It's just not quite exactly right. This has been a bit of a disappointment. I will win, just not today. But with enough screws to hold it together as a proof of concept, this actually looks pretty good. I'm pretty happy with where this is. You can see the back there is suspended a little bit above the top of the grinder. I'll adjust those M8 screws back there just to give it solid bearing. I think I'm going to eventually want to put something soft under them just to give it a little bit of compliance. But in terms of how this fits on the grinder, visually how it looks, how the controls work, where they are ergonomically, I like this. It remains to be seen if we're going to have problems with grit and the touchscreen there, but I think I'm going to move forward with this anyway. I like how it looks. I like how it fits. I like the feel of the controls. This is a win from a start from a blank slate, kind of have an idea of what I want and get it all the way through to a functional prototype. This looks really good. Have I mentioned that I like the chicken head knobs? I like the chicken head knobs. There's still lots more to do. First off, I need to find a material I can use to successfully print the case. Then we need to laser mark the graphics on the panel. We need to wire everything up and test it. And then there's the software development for the control systems and the HMI. I'd love to have it all done already, but it's going to be a long grind. If you enjoyed this first look at the process, give the video a thumbs up. Feel free to subscribe and maybe think about supporting the channel over on Patreon. The drawings and CAD files for everything you saw today are available there to download, and you can join the ongoing discussions about this project in the forums. Also, feel free to leave me a comment telling me your ideas for the project. I'd love to hear them, and if they're good, I might just use them. Thank you for watching.